Alright, and welcome back. And in this video, we're actually going to start looking at graphing cosine. So if you haven't watched the videos for graphing sine, I definitely recommend you do so because graphing cosine is almost the exact same, just one small change, but everything else remains the same. And I'm going to start this off the same way we graph sine, okay? So if you want to take a second and pause the video and evaluate these five, we're going to use these to graph cosine. So go ahead and pause the video and do that now. Okay, so remember with graphing cosine, or not graphing cosine, just evaluating cosine, basically all we're thinking about is what is the x-coordinate at that particular angle. Okay, so at 0, x is 1, so cosine of 0 is 1. And cosine of pi over 2 is 0. And cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi, 1. Okay? So let's go ahead and use these values in graph. Okay, so I'm going to go ahead and make a table. Our independent variable was the angle. That could change, and what depended on the angle measure was the coordinate, which is the y. So at 0 we're at 1, and 0, then negative 1, 0, 1. Okay, so let's go ahead and make a graph. All right. So we go up to 1, down to negative 1, and notice once again I'm going by pi over 2. So I had pi over 2, pi, 3 pi over 2, and 2 pi. Now, remember when we were graphing sine, it started at its midline. However, cosine actually starts at its maximum. It's up at 1. Then it goes down to 0. Then it goes down to negative 1. Then it goes up to 0. And then it ends its cycle at the maximum. So this is a little bit different than sine. Sine normally started at the midline, then rose and fall, rise. However, cosine starts at the top, all right? And then it goes down. Okay, so this is the graph of cosine. This is y equals cosine of x. Okay, and if I'm going a little fast, it's because this is really the exact same type of function as sine. It's not the exact same function, but graphing it is very, very similar. Okay, because this is still another example of a periodic function. It does the same pattern over and over and over again. And we unwrap the unit circle. We go along this unit circle the exact same way. Notice how I went through each angle the exact same way. I started at 0. Then I went to 90 degrees, or pi over 2 radians. And I went to 180 degrees, which is pi radians, and so on and so on. We unwrap the unit circle the exact same way we did with sine, which I'm going to show you in just a second. Notice how once again we're just going along the unit circle. Instead, we're just starting up at the maximum, but then we continue that same wave-like pattern the same way sine did. And notice the pattern once again ended at 2 pi. Okay, it started at its maximum, it went all the way down to its minimum, and then it went back up to its maximum again, which we're going to see in just a second. That is one full pattern, max to max, okay? So that is one cycle. And notice once again, the length of that cycle, 2 pi, okay? So the period is still, once again, 2 pi. And once again, notice how it never goes above 1 and never goes below negative 1, which means the amplitude is once again 1, okay? So a lot of the same information here. Well, the amplitude of cosine is once again 1. The period is once again 2 pi. And the midline is once again, at first, y equals 0. Okay, so let's go ahead and jump right in to how we can change some of these values. So with cosine, given y is equal to a times cosine of bx plus k. Once again, just like with sine, to find the amplitude, it's once again just the absolute value of a. Okay, that's all that the amplitude is. For sine and cosine, the amplitude is always just the absolute value of a. Once again, if a is negative, that just means that it's reflected over the x-axis, which means the pattern's actually reversed. Okay, and we'll talk about that in a second. Once again, to find the period, we also just do 2 pi over the absolute value of b, just like with sine. Okay, and just like with sine, to find the scale for the x-axis, we just go ahead and take the period and divide it by 4. Okay, and the midline, kind of skipped the I there. The midline is once again by finding whatever that vertical shift is. This value of k, if it got shifted up 2, the midline's at y equals 2. If it got shifted down 3, if it was minus 3, be y equals negative 3. So all of these values are the exact same. Okay, the exact same way we find everything with sine, that's the way we find everything with cosine. So in the next video, we're going to jump right into graphing something like, let's say, 3 cosine of 2x. So we're going to jump right into the next video, graphing this particular function using what we have learned. Okay, so pay attention and try this out if you want to. If you want to try it out right now, feel free to go ahead and do so. And in the next video, we'll go ahead and tackle this problem.